Hello students, in this video I'm going to explain the definition of rate of current and the definition of a closed circuit. So for this lesson, which is entitled by electric current, we're going to encounter the following terms, which are the electrons, electric current, electric circuit, conductor, insulator, multimeter, ammeter, voltmeter, voltage, volts, ampere, resistance. Objectives: students should be able to represent an electric circuit using symbols of common electric components, define an electric current, determine the direction of a flow of direct current, measure the intensity of an electric current using an ammeter, definition of voltage, define voltage, measure the voltage across an electric component using a voltmeter, and finally describe the effect of resistance on the flow of current. So how is an electric current made to flow? Sushi dishes ride along a conveyor belt as shown in the adjacent figure. The conveyor belt carries full dishes past customers and carries empty plates back to the kitchen. You might be wondering what a conveyor belt of rice, vegetables, and fish could possibly have to do with electricity. Like sushi plates, electric charges can be made to move in a confined path. The conveyor belt represents the electric wires. If more plates pass through you in the same period of time, then a current of a greater intensity is considered to be passing through a point in a circuit. Electric current, dynamic electricity. As a definition, an electric current is the rate of a flow of electric charges through a point in a closed circuit. By rate of a flow, we mean the number or the quantity of charges per unit time. So we are going after a while to use the simulation to show you the definition or to show you what do we mean by rate of a flow of electric charges. So we're going to concentrate on one point in the electric circuit and study the quantity of charges passing by through this point in 1 second. Let's consider two circuits. A circuit here composed, a simple circuit composed of a battery and a light bulb connected by connecting wires. And another circuit here, which is constituted of a battery and two resistors and a lamp. What is a resistor? A resistor is an electric component that resists the flow of electric current. I used it here in order to decrease the rate of flow of electric current or the rate of flow of electrons in the circuit. So now let's do the comparison. As you can see here, in this circuit in which the electrons appear to be moving or flowing at a high rate, such that every second in this point in the circuit, an electron passes by. So if you count one, you find an electron passing by. However, as for this circuit, you can see that the electrons are really moving so slow that one electron needs about 3 seconds or 4 seconds to reach this point, to pass through this point. So this means that the rate of flow of electrons in this circuit is greater than this one. What about the intensity of the current? You can see here that the lamp is glowing brightly. However, in this case, the lamp is glowing weakly. So this means that the intensity of the current here is greater than the intensity of the current here. And the current, by definition, is the rate of flow of electrons. So the brightness of the lamp confirms that the intensity of the current here is high and that the flow of electrons, the rate of flow of electrons is high too. However, in this case, the dim glowing of the lamp confirms the low intensity of the current flowing through the circuit and thus confirms the low rate of flow of electrons. So the electrons go from the negative to the positive, while the conventional electric current goes from the positive to the negative, as you can see. So here you can see that the flow of the electric current is higher, the speed and the rate of the electric current is greater than this one here. So this is another activity that proves what we said. So if you compare the number of charges flowing during the same interval of time through the region marked with red in each of the two wires represented in figures A and B, we can see that these are the two marked lines, and here we have 8 electrons, while here 4 electrons passing by. So the number of charges passing through the marked region in figure A is greater than that in figure B during the same interval of time. So it's very important here to mention during the same interval of time, because we said that the current is the rate, and when we talk about a rate, this means that we are taking the time factor into consideration. How many electrons pass by per unit time? Okay, not in general, not in for up in time. How many electrons pass by in a certain period of time. Number two, compare the intensity of the electric current in both cases. So what do you think? If more electrons during the same interval of time pass in figure A than in figure B, this means that the intensity of the electric current in figure A is greater than that in figure B. Now moving to the concept of closed electric circuit and opened electric circuit. So a closed electric circuit is a complete unbroken path that allows the flow of charges through it. This is a closed path. The current comes out of the positive terminal, passes through the closed circuit, closed switch, sorry. So how did I know that it's a closed switch, and how did I know that there is an electric current passing by? Because simply the 3 lamps are glowing, are on. So for the lamps to glow, it is necessary that a current be traversing them. So the current comes out of the positive terminal, goes through the closed switch, through the wires, and through the lamps internally. These two wires, these two terminals are connected by a wire. Again, through the wire to the terminal, and I said internally that two terminals of the lamp are connected by a wire. Similarly here, connected by a wire, and so on, and the two terminals of the battery also are internally connected by a conductor. So this is a closed path. However, for this figure here, which is composed of a battery, a ring, and a switch, an opened switch, if the current tends to flow out of the positive terminal of the battery, here it goes out to one terminal of the switch, then goes through this conducting part until it reaches this insulating part. This is insulated because if one needs to touch it, to put it off and on, or to open and close it, that's why this part is an insulating part. Anyway, the current goes to this part, then finds no other way to go through. So actually it doesn't flow. If this switch was closed, if it was closed in contact with the other part, with the other terminal, then the current is going to flow through the wires and through the ring internally, turning it on then to the other wire connected to the negative terminal. This is true only if the switch was closed, providing a closed pathway for the current. Otherwise, if it's open, no current is going to be flow. That's why we consider this path to be a broken path. It's broken here, okay, due to the presence of an opened switch. However, the other circuit here is closed. The current comes out of the positive terminal of the battery through the wire, reaches the first terminal of the lamp, goes internally through the wire, and then comes out of the other terminal, passing through the wire into the negative terminal and internally, and so on. So this is a closed circuit. Here are some electric devices that are made up of electric circuits: air conditioner, heat pump, control panel, space heater, water heater, flat screen, sewing machine, fan, radiator, iron, microwave oven, desk lamp, washing machine, vacuum cleaner, dryer, refrigerator, dishwasher, stove or oven, and so on. So many other ones that we use in our daily life. That's the importance of studying electric circuits.